Well, in this module, I'm going to teach you the basics of how to run a simple OLS regression model in R. Now, since I've stated from the beginning, this is only like an intro to OLS and R in general. You could take an entire course in OLS, and many of you probably already have. This is not about teaching you the fundamentals of OLS. I will perhaps create another video later that has more information on OLS, but for now, I just want to teach people how to take their data set and import it into R and run a regression if they want to. So for us right now, we already have a data frame, okay? And what we're going to do is just run a simple OLS model based on what we've talked about in previous modules. So let's take a look. So what I want to do, let's first look at our data again, okay? And you'll see that, we have happiness, we have job satisfaction, and job stress. We're going to call happiness our dependent variable, and these two are going to be our IVs. So theoretically, it makes sense, right? The job satisfaction and job stress might influence the performance of the employee. And so that's what we're going to test. Now, I should also say this, again, I created the data of the simulation, but we probably would not want to use OLS for this in general because the data are grouped. In other words, these observations are not independent because they belong to the same group and the same here. So therefore, their residuals will likely violate the assumption that they are independent. But nevertheless, that's not what this is about. Instead, this is about just showing the code. So I'm highlighting it here, but what you'll see is that we're using this function. This is all in base R, by the way. We're using the LM function, and that just stands for linear model, all right? And what we're going to do is say we're going to create a linear model, and in the parentheses, happy is our DV, and this is kind of like the equal sign, okay, in this modeling. And so we're going to say the independent variables, all right, job satisfaction plus job stress, and the data set is RM data. Now I want you to also notice that we're going to call this something OLS1. We could call it whatever we wanted. We could call it job sat 1. We could call it happy 1. We could call it happy 1,000, whatever you want to call it. But some people in R, including me, at the very beginning of using R, get really confused by this because you highlight it and you look up the code and you hit run and you think, well, that's interesting. It ran, but I don't see anything, right? Because usually in Stata or SPSS or SAS, when you run an OLS model, you see the results. So what we need to do is invoke another command, and that's summary, all right? And we're gonna ask for a summary of OLS1, all right? And in fact, OLS is like an object now. Okay, you see all this kind of nasty stuff, for lack of a better technical term, and you can see the coefficients listed here, and it's actually kind of cool because if you run simulations, you can actually dive into this and extract these different elements. But not now. What we're going to do is just provide a quick summary, and this should look a little more familiar. All right, so you can see that here's the formula. And here are the results. You have your coefficient estimates here, your standard errors, your t-values, and your p-values as well. And so you can see in this example, job satisfaction is positively associated, okay, and job stress is negatively associated. So both of those are also statistically significant with very high t-values and very low p-values. Okay, and you'll get some other statistics down here, such as the R squared, the F statistic, and the overall p-value of the model, degrees of freedom, and so on and so forth. So this is how you run just a basic OLS regression. Okay, not too bad, right? I mean, all you have to do is load your data, use this command, you declare which database you want to use, and then you just put DV, this little squiggly mark. I'm sure there's a name for that. Then your IVs here, and you have your results. Now, base R also has a pretty cool way to check some of the assumptions. Again, I'm not going to go through all of these, but you'll see it's just the plot command. And it gives you this down here, this interesting hit return to see next plot. Okay, let's do that. Whoops, I gotta go down here though. Click here, then hit return. And it just gives you kind of some of the residual plots that you can inspect and see if these violate any assumptions. Okay, so pretty cool. Pretty cool way to see what's going on. Now I also want to show you, if we go back here to the coefficients, I mean, it's not pretty, right? I mean, this is, when you look in a journal, this is not what it looks like. So there is another package known as Stargazer. So if you'll go to packages, install this, packages, install, look for Stargazer and install, all right? And then you'll load that library. And it gives you a little citation here. And then what I want to do is say, I'm going to use the Stargazer command for OLS, or for model OLS1, and I'm going to give it the type, the output, and the title. And again, you can look at the commands here. You can do more investigation and see what everything means. But here's the bottom line, is it makes it look a little different, right? It gives it a title, my first model, and it looks just a lot nicer, right? There are also some specific formats for journals that you can put in. And so in this case, I'll use the ASQ, Administrative Science Quarterly. And you'll notice like style is ASQ here. And I'll hit enter to run. And this is a little different, okay? It doesn't have the asterisks here, if you'll notice. I guess that's not in ASQ style. So anyway, so there are a lot of different options here, but the idea here is that it's pretty easy to run a regression model in R. Right? You know, it's somewhat intimidating because you actually have to type out the code instead of using drop-down menus and point and click and put your variables in. But this is just as easy, and honestly, you have the code here. And so whenever you run a model, you'll have the written code and you'll know what you did. And so even though your model will not have happiness and job satisfaction, just use this format, right? That's why I'm including the code so that you can use what I've used and just modify it as you need it, okay? So hopefully that's enough to get you started in regression. Again, it's not everything you need, but it's enough for you to at least feel comfortable running a regression model with your own data.